Today, I'm working on a Python data capstone project. This project is called 911 calls, and the data has been pulled from the Kaggle website. We will explore and analyze the dataset to understand the density of the calls made during different hours of the day and different days of the week and months, where those calls are coming from and for what reasons, to help improve organizational efficiency. Please watch along if you find it interesting, or feel free to work alongside if you want to practice these codes too. The dataset has been linked in the description box in case you want to code along to practice your Python skills. You can download this dataset and move it in the same folder as the Jupyter notebook that you would be using. So let's get started. So here we will start by importing some libraries. Import NumPy as NP, import Pandas as PD, import matplotlib dot pyplot as plt, import cbound as SNS, and then we will run %matplotlib space inline. This one line code is used to show the visualizations in the Jupyter notebook. Next, we will read the 911 calls CSV file as a data frame, and we will name it as df. Just press tab as you begin typing, select read underscore CSV, then within inverted commas begin typing again, and then press tab. It will auto complete the CSV file name and then enter. Now we will check the info of the data frame. So as we see here, this is a data frame which has 99,492 rows with row index ranging from 0 to 99,491, and there are 9 columns. We have latitude, longitude, these are float data. Then there's description. Let's do one thing, let's check the head of this data frame as well. And now as you can see, we have this latitude and longitude column. Those are float data. There are no null values. Then we have description of the call, which again has no null values, and it's given as an object. The string is always given as object data type in the data frame. Then we have zip column, which has some null values, as you can see one here. So here we only have 86,637 non-null values. That means there are about 13,000 or more null values in this zip column. Then we have title, which explain what kind of call that was. This is again an object. There are no null values. Then we have timestamp. This is again given as an object, so it is stored as a string. Then we have township, and we have address, and we have a column E which has no null values, and it is an integer. I think it is always 1 as it is given in this data frame. Let's just quickly check that. We can do a value counts check. See, there are 99,492 ones. It's always 1. Now next we will begin analyzing this data. So first question is, what are the top 5 zip codes for 911 call? So we have our zip codes here. So here what we can do is, we can do a value count for this column. So this will return a series with all the zip codes available with their frequency, and this frequency will always be arranged in a descending manner. If you check the signature of this method, we have this ascending parameter which is given as false. So by default the data will always be arranged in a descending manner. If you want the data to be in ascending order, that is going from least frequency to the most frequency, you can pass in this parameter ascending and return true for that. Here we only need the top 5, so we'll take a head of the series and we get our zip codes which has the maximum number of calls coming from those, and the answer here matches to our answer already given here in the Jupyter notebook. Next we have to do what are top 5 townships for 911 call. So we will use the same method here. Select township column, then do a value count, and we will use head method to get top 5 rows. And if you match the answers, we have the township as Lower Merion, Abington, Norristown, Upper Merion, and Cheltenham, and the data matches as well. Next, take a look at the title column, how many unique title codes there are. So let's check this title column first. So we have to find how many unique title codes there are. There are two ways we can do this. One is to use the unique method. This will return all the unique values in this series, and we can check the length of this array here, and that returns 110. The other method to do this is directly use the nUnique method, and it will directly return the number of unique values in that series. Next, we have to create some new features. The title column, there are reasons/departments specified before the title code. These are EMS, fire, and traffic. Use.apply with a custom lambda expression to create a new column called reason that contains this string value. So here we have to create a new column with the name of the column being reason, and we have to take this title code and put this in the new column. So here call the column as if it's already exists, and then this will be based on the title column. If you just use this, then in the reason you will have the exact same data which is there in the title column, but we will change that data here using the apply method. We will use a lambda expression for a custom defined function, and what that will do is when we take x, for x it will do a split, and here if you see this data here, we can split it with this colon, and what this will do I will show you first. Let's say this is x, and what is x? That will return the value in the first cell in that series. Now we can take this x and split it based on colon. So what this will do is it will split the string based on this colon. Everything before this colon will become one string, and everything after this colon will become another string. Now we need this EMS here, so we can index it to get this element. Now it will return only EMS. So this is what we have to do here. So we'll pass in this 0 index and run this. Now see what happens when I call this column reason. So it returns a series which has the EMS, fire, and traffic listed based on the title column. Let's check the head of the data frame. Here we have our new reason column, and the reasons are listed here taken from the title column. Next is, what is the most common reason for 911 call based off this new column. So once again we can do value count here. And here there are only three values: EMS, traffic and fire, and we have the frequency of those. So the most common reason for 911 call was the EMS, that is emergency medical service. Next was traffic, and the list was fire, and by some fair distance. So most of the calls were made for EMS, followed by traffic, followed by fire. Now use cbound to create a count plot of 911 calls by reason. So what we will do here is sns.countplot, and if you check the signature, we need to pass in a data frame. Then we will pass in either one of x or y. Because this is a count plot, if you pass in the x, the y would obviously be count, and if you pass in the y, it will plot horizontal plots and x will be the count. Our data frame is df, and on x we have to pass it by reason. So this is our data frame. So there are a couple of things to note here. One is all of these are in blue color. If you want this color palette, this is Viridis palette, so we can pass this here. So ignore this warning. We got our color parameter matching what is given here already. Now notice the background, that is white grid style, and here we have just white background. So we can change that. We can change the figure size as well, and notice the levels and data given on the x-axis and y-axis is much bigger, and here it is smaller. So we want to adjust these three things. So what we can do here is we can define those parameters. We will go back to the top of the notebook, because those would be global parameters. Insert a column. The first thing we will define is the figure size. For that we will use plt.rc params. Select this and then press tab. Start typing figure, then press tab. We'll select the figure size and then define the size you want, pass in the coordinates for that. So here we will let me go with 4.5 and 3.5. that is the size of the figure in width and height that I want. Then the next is I want to set style for the notebook. Here there are two parameters, style and RC. If you go down and check the style, we have these four options given here: dark grid, dark white and ticks. What we have currently by default is white, and what we are looking to change this to is white grid. So we'll pass in that. Next we will select context. Here we have a context parameter and then we have a font scale. If you go down and check, so here as you can see we have four options given from paper, notebook, talk and poster. As you go from left to right, the font size will become bigger and bigger. The options given for talk and poster are very good if your audience is far away from the visualization and you want them to read what is there on the x-axis and on the y-axis. For normal purpose, just for using Jupyter notebook, we can use paper and notebook. So here I will use the context notebook. And then for font scale I will make it 0.7. Now this will be global. Now all of the visualizations that I plot today will be based on these parameters. Let's go back to our count plot. Let's run this again and see. Now the size has become smaller and the background has become white grid, and the data on the x level and y level have become smaller as well. So what we notice here is, if you look at the number of calls by EMS, that is about 40,000 something, less than 50,000. For fire it was about 1400, and for traffic it is less than 40,000, so about 35,000 something, and that's the same data we have got here, but visually we can see the difference between these. Now let us begin to focus on time information. What is the data type of the object in the timestamp column? So let's check the data in the timestamp column now. Press tab, press enter, and this will return all the data in this column. What we could do is use dtype, and this is returning an object. And as I said earlier, Python data frame by default stores all the strings as object. So to check the exact data type, what you could do is select an individual cell in this column and pass this through type, and this will return a string. Now we want to convert that into a DateTime object. What we could do here is use pd with method pd.to_datetime. We have this options here to convert the data. Here we will use the DateTime method and pass in that data. Now let's check that data. And see, when we use the exact same code earlier, we got data type as object. Now it is returning data type as a timestamp. We can further check the individual data in this column, and this will return a timestamp type. Now we can grab specific attributes from DateTime object by calling them, for example. So let's check this. Pass this timestamp as time, run this. So here let's call this time object, and we can check various attributes of this. For example, you can pass in hour here, and it will return the hour of the time. Let's check the actual time object. So this, as you see, is a timestamp object which has the actual date and time for that particular row. If you call the hour of that, it will return the hour as 17. If you call the month, it will return 12, which was the month. You can also call in the month name. Pass this as callable function, and it will return December. You can press tab and check various methods which are given here. You can check if the time was a leap year, was the month end, month start, quarter end, quarter start. All of these are options. What year it was, what month, what date, what hour and minute, all of those options are available. So it returns the fourth quarter as it is December. So this column now is a DateTime object. We have to use the apply method to create 3 new columns called hour, month and day of the week. You will create these columns based off of the timestamp column. So what we have to do here is create new columns, one for hour, one for month and one day of the week based on this column, timestamp column. So what we will do is take our timestamp column, use the apply method, pass in the lambda expression, and for the data what we have to do is take that data and use .r method and this will return the R as we saw here to this column. And we could do the same thing for month as well. And day of week as well. Now let's check the data frame again. So as you can see here, we have got our additional columns for hour, month and day of week. The hour column has the hour data from the timestamp in each row. The month column has the month data, and day of the week has the day of the week data, but it is given as number. So notice how the day of the week is an integer given between 0 and 6. Let's check this. Yeah, so we have day of the week as given between 1 to 6 and 0 is there as well. So 0 to 6, and the frequency of each is given here, and the data is an integer. So notice how the day of the week is an integer 0 to 6. Use .map with this dictionary to map the actual string names to the day of the week. So what we are going to do is we will change this day of the week column from the integer to this actual day of the week, which we could read and is a lot more intuitive. So take this column, day of the week. We will use the map function, and here we will pass in this, but first we have to run this dictionary here. Now pass this dictionary object inside this mapping function, and let's check our data frame again. And you see how all of those integers are now converted to the actual day of the week. Let's do a value count again to see the values. And now those integers are given as actual days of the week. Here it was given that 0 is Monday, so week starts from Monday, and this 0 to 6 is actually a range index going from 0 to 6. So first day is Monday, that is 0, Tuesday is 1, Wednesday is 2, 3 for Thursday, 4 for Friday, 5 for Saturday, and 6 for Sunday. Now use Seaborn to create a count plot of the day of the week column with the hue based off reason columns. So let's do that. We'll call the count plot. Here we have to pass our data frame. Then on the x-axis we have to pass the column based on which we want this plot. So let's pass day of the week, and let's see what this produces. So see here, the days are not arranged properly, but what we have is it starts on a high note on Monday, Tuesday, Wednesday, and then Thursday, Friday, and goes down on Saturday and Sunday. Now we need this based on hue as well for different reason. So let's use this color map by passing in the palette, which is Viridis, and then here we will now move this legend box outside the actual graph. So for this we'll use plt.legend, and use the parameter bbox to anchor and pass in a tuple where you want it to be. So I want it just outside uh, this x coordinate and at the top of the y coordinate. So let's check what this does. Yeah, so now it is outside. This is good. So the question was to use Seaborn to create a count plot of the day of the week column with the hue based off the reason column. So here, if you check this graph based on the day data, we see the fire data is somewhere, fire call is somewhere around 2000 each day. If you go back to our previous count plot, this was based on overall data. For entire data set, we had about 50,000 calls for EMS, about 14,000 calls for count, and about 35,000 calls for traffic. Now, when we plot this by day, what we found was the this dark green is fire. The fire calls were consistently around 2000 mark on each day of the week. This light green is traffic, which is higher on Thursday and Friday and then goes down on Saturday and Sunday and then again up on Monday, Tuesday, Wednesday. So basically on the weekdays we have more calls on Monday, Tuesday, Wednesday and Thursday and Friday here, and it goes down on the weekend. And kind of similar pattern is observed for the EMS calls as well, but to much lesser extent than compared to the traffic. Now let's move on. We will do the same for the month data. What we did here was we used the count plot for day of the week. Now let's check for the monthly data now. If you check our data frame, we have an hour column, we added an hour column, we added a month column, and we added a day of the week column. So let's check for the monthly data now. So here for the legend, just the BB box argument was not working. What BB box to anchor does is it puts an anchor somewhere around this point, and then we can move the location. Just how we can move this legend using the location inside the actual graph itself using different numbers from 0 to 10. Similarly, we can move it around this anchor point as well. So 2 is on the upper right side and we got our legend outside the main graph. Now here, once again, if you see based on this monthly data, this is going from 1, 2, 3, 4, 5, 6, 7, 8, and then we don't have 9, 10, and 11. That is September. We don't have September, October, and November data. So as the year goes on, we see the number of calls comes down, and we see this pattern for all three reasons, whether those be EMS or traffic, which is in light green, or for fire, which is in dark green. So we will do one thing. Did you notice something strange about the plot? You should have noticed it was missing some months. Let's see if we can maybe fill in this information by plotting the information in another way, possibly a simple line plot that fills in the missing months. In order to do in order to do this, we will need to do some work with Pandas. We noticed that the monthly data for each of the regions EMS file and traffic was going down in August and December, and we had missing data for September, October and November. So here we have to create a group by object called by month, where you group the data frame by the month column and use the count method for aggregation. So what we will do is name this object by month and use group by the month data, and we will use count aggregation. So let's see what this produces. So here we have grouped the data by the month column. So for each row for any given month, we have one added to this individual columns. Now if you see here, just for the first month, you will see we have different data for uh, zip and township and address compared to the other columns. And if you go back to the info of the data frame, we check at the start of this project, we had some null values for the zip column and for township and for address columns. So for further analysis, we will ignore those columns. So what we have to do now is to create a simple plot of the data frame indicating the count of calls per month. So here we are looking for this count of calls per month. What we could do is take the data frame, use the plot method, and here if you check the signature, we have to pass in the data, and then we have options for data on the x-axis and y-axis, and we have a kind parameter as well, and by default that is given as line, so we don't need to specify that. But in place of line graph, if you want to plot bar graph or histogram or box plot, then you can select these different kinds here. So for first one, the kind is line. This is given by default, so you don't necessarily need to select this. Now for x, if you don't define anything, it will automatically take the data from the index. So we will let it be, and we will use for y, we will use this e column here, which was given as dummy column, which data in each row as 1. So the count should be perfect for each of the added up rows. Apart from e, you can also use any of the columns here except this zip, township and address, as those columns had some null values. So let's plot this. So we made the mistake, we passed this in on the df data frame where the value of e was 1 for each row. What we need to do is pass in to this new data frame we have created by month. And now to remove this legend, you can pass in the legend parameter as false, and we will also restrict our xlim just to 12 just for the aesthetic purpose. So here the plot matches to the given plot. If you want to remove this text, you can pass in a semicolon at the end of the code. Now what we see here, that the number of calls based on this monthly comes down from January, then it goes up during the summer months, and then falls up drastically for the October and December data. And this also produces an estimate for the number of calls for the missing months. Now see if you can use Seaborn's lmplot to create a linear fit on the number of calls per month. We will use regression To get an estimate of the calls in those missing months, keep in mind you may need to reset the index to a column. Okay, so for the LM plot, we need to pass in both the x parameter and the y parameter. So what we'll do here is use this by month data. Actually, for LM plot, we have to do sns.lm plot, pass in the data as a parameter. But before that, we will reset the index by month, reset index, and what this will do is it will convert the index into a column, and we will do this in place. Let's check this, and now that monthly index has become a column here. So for this LM plot, we will do data is equal to by month data frame. Now this month here is a column. We'll take that on x-axis. On y-axis, we will use our E column, and let's pass this. Now we will make some further adjustments here. If you check the LM plot signature, you have an height and aspect given here. So this overrides the original figure size which we have defined globally as 4.5 and 3.5 pixels. So this by default is giving you a 5x5 picture, 5x5 graph. We can change this to, let's say, 4. Now it will give a smaller visualization. We also want to decrease the size of the scatter plots in the line. For that, you can pass in scatter keywords, pass this as a dictionary, and for the size we have the S parameter there in the scatter plot, and let's go with 10 and see what that produces. So it's small enough now. Then to change the width of the line, we can pass in the line keywords. Once again, we will pass it as a dictionary, and we have the line LW parameter for line width there, and let's go with 1. It is too thin, so let's try 2, and now it looks okay. So here this graph has produced a fit, and this shadow here is the error. So what we see as we go from January to December, the regression analysis is showing that the number of calls per month goes lower and lower. However, if you see the actual scatter points here, it goes down and then goes back up again before it crashes in August and December, and that's why it is showing a much larger margin of error here with this shadow portion. So the actual data points could lie anywhere from 9,000 to 12,000 for this month 10, that is October. So it doesn't give a very good fit here because of this high error. Now create a new column called date that contains the date from the timestamp column. You will need to use the apply along with .date method. So what we will do is call the date column as if it already exists. We will use the timestamp data, and here if I show you what does, if we take a look at our time object again, remember it was the first row from the timestamp column. If you call this date method here, it will return you a timestamp date of timestamp object. If you actually call this, it will return just a DateTime object which contains just the year, month and day, not the time data. Similarly, we can call in our time method as well, and that will return the actual time, that is hour and minutes. So what we could do here is use this apply method with lambda expression. and for data in each row, what we have to do is use a date method, and that will pull just the date information to this new column. Now let's check the head of the data frame, and here you can see in the last column we have created a new column called date, which has just the date information. If you want to check the data type of that column, it is an object, and it is a DateTime object. Now group by this date column with the count aggregate and create a plot of counts of 911 calls. So here we have to create a plot like this by grouping the date column. Group by date and take the total count. So in this data frame we have a total of 259 rows. Let's check the head of this data frame. Now here all of the data has been clubbed or grouped by individual dates, and we have the data here we have the total count here for each of the columns. Now remember, zip, township and address had some null values, so we will ignore those and use other columns for our visualization. So to create this graph, we will use this by date object. Plot kind is line graph, and for y we will use the e column. So here we can hardly read the data on the x-axis, so we can increase the width of this figure using the fixed size parameter. And we will also remove this legend, we don't really need that here. So as you can see here, just notice that this December data is from 2015. The data starts actually from December 2015, then it goes to January 2016, Feb, March, April, May, June, July, August, and ends in September of 2016. Actually, it ends in August itself, just before it reaches September. So rather than what we were thinking is we have missing data from August till December for the year 2016, the data itself starts from somewhere in December 2015 and continues only till August 2016. And that's why we were getting the total count of the calls were getting dropped for December and August, because I think the data is not for complete December. In fact, if you check here, the first date, the head of the data frame showed it was 2015 December 10th. Now let's quickly check the tail as well. Yes, see, so the data starts from 2015 December 10th and it ends on 2016 August 24. So we have data missing from August 25th, 26th and onward, and we don't have any data before 10th of December in 2015 as well. That's why the total number of total counts of call is less in August and December, because we don't have the data for the complete months. If you analyze just this data, this is the total call by date. On any individual day, it looks like the total number of call varies between 300 and maybe 420, with spikes on certain days. On this particular date, there were more than 900 calls, and then this was in January. Then in Feb, on this day, there were about 600, little less than 700 calls. On this day in April, there was about 600 calls, again 600 calls in July as well. And there were some days where there were very little call, like on this day. We can't really read much on at the start and the end because we don't know the time of those data. But on this day, there was a spike on the downward direction. This is at the end of the April, where there were less than 200 calls. It looks like there were only 150 calls on that particular day. Now we'll do one thing. We will recreate this plot, but for different reasons given for the 911 call. Remember, those were EMS, traffic and fire. So what we could do is we could filter the data frame for individual reason and then plot this graph. So we will start with filtering this for traffic. And now we will use our group by, which we did here, by date. On these reasons. And then we can plot our graph on this data frame. Let's check this data frame first. So here, as you see, we have the same data frame by date, but the number of count is lesser as we have filtered the data frame for just the traffic reason. So we can plot on this data frame. And we can also pass in the title parameter here to give a title to this graph by the reason. And if you want to remove this text from here, you can pass in a semicolon. So if you see this graph just for the traffic reason, the data, that is the number of calls each day, is varying between 80 and 200 with spikes on certain days. Now next we have to do that for fire. Filter it for fire, then group by date dot count. Let's check the head of this data frame. Now we will plot here. And we'll pass in a title as well for fire. Here if you see this graph, the pattern matches with the given graph here for fire. It looks like the number of calls varied between 40 and 80 per day with spikes on certain days. Next we will do the same thing for EMS as well. Group by date, use count aggregation, and let's just check the head of this data frame. Now plot the graph here. And the title for this would be EMS. And here it looks like the calls on each day were between 150 and 225 with spikes on downward direction on at the end of April or the first day of May. And we see that here as well the counts are mostly between 150 and 225. Now let's move on to creating heat maps with Seaborn and our data. We will first need to restructure that data frame so that the columns become the hours and the index become the day of the week. So we need the day of the week on the index and hours on the columns. So we basically need to create a matrix data set. So there are a lot of ways to do this, but I would recommend trying to combine group by with an unstack method. So the easiest way to do this is actually using the pivot table. If you check our data frame again, this is our original data frame. We have added these new columns: reason, hour, month, day of week and date. Now what we want here is this day of week to be our index and this hour column to actually be columns. So this hour varies from 0 to 24, 0 to 23 rather, right? So we want 24 columns for each hour of the day and we want 7 rows for each day of the week. The easiest way to do this is use the pivot table. If you check the table, we need to pass in the values, the index and column. So here for index, we can use day of week. For columns, we can use our hour column, and we need to pass in some values for the matrix. We can use the E column, which is basically one for everything. And now there's another parameter here which is called aggregate function. So what this produces is the aggregate on that data we are clubbing. So by default it is given as mean. We should use sum here because we want the count of each row. If you just use mean, it will produce 1 for all the cells by default. See, so what we will do here is use this function, use this aggregate function and pass in sum. This is numpy sum function. So it will do sum of all the rows and we have our data in a matrix format. Now this is the easiest way of doing it. What this question asks here is to try the group by method with unstack method. So I will show you how to use the group by and unstack to produce the same data frame. Here what we will do is use the group by method, and rather than grouping by one column, we will group it we'll pass in a list of 2 columns to group it by, and that will produce a multi-index data frame. So we will use our day of week and R. Let's see what this produces. We need to pass in an aggregate function, so we will use the count method, and what it produces is, you can see we have 2 index here. One is day of the week, and then we have the R for each day of the week. Now if you use the unstack method on this, so what this unstack will do is, it will take this second index. So remember, the index of the multi-index would be 0 and 1 if you go back. So the day of the week would be 0 and R would be 1. So here for unstack, which of these index do you want to come at the column? So which level of this multi-index do you want to appear in the column is based on this level parameter. So if you pass 0, the day of the week will come in the columns and the R will remain in the index. So let's check this. So we have our data on the row index, and the day of the week has come in the column. If you pass in 1, it will be the reverse of this. It will be our day data here and our data here in the column. By default, it is given as -1, which means it starts at the end of the last level of the multi-index automatically. So that will be our data. And now let's see, we only want, so what's happening here is we have this data for all of these. If you go back, so we have all of these columns here. We want this data only for one column, so we will select our E column and then use the unstack method. By default, the level is going to be -1, so it will convert this R index into the column. So now this is a 7 by 24 data frame. We have 7 days of the week and 24 hours ranging from 0 to 23 column, and we have this sum, that is the count for each row, which has E value as 1. Now let's give this data frame a name. Next, we have to create a heat map using this new data frame. So for that, we will use the seaborn heat map method. Pass in your data, and then we will pass in the CMap parameter. This semicolon will again remove this text from here. We want to increase the size, and unfortunately for heat map we do not have a fixed size argument or parameter given to adjust the size, so we can pass in the matplotlib parameter. plt.figure, use fixed size parameter, and we will pass in 9 by 5 here to increase the size of this figure. Now here, as you see in this color bar, the darker color has lower value and the lighter color has higher value, which is not very intuitive. So I am going to reverse the color here, use _R at the end of the palette here, run this, and now the lower values have lighter color and this yellow turns into green, which is darker for higher values, and if you go even higher, the colors become darker and darker. This is intuitively much more easier to understand. And this is now a visual representation of what we have done above. We have the days of the week on the y-axis, and we have the hour data on the x-axis. So here what you can see is on the night time, that is midnight, then 1 a.m., 2, 3, 4, 5. This has yellow and green color, which is at lower value. And then as you go through the day from the morning to the afternoon, late afternoon and evening, the colors become darker and darker as you go through the day, and then start getting lighter again as you reach 9 p.m., 10 p.m. and 11 p.m. Similarly, if you look at the y-axis, the day of the week, it has the lighter data on the weekends, Sunday and Saturday, compared to the other days, Monday, Friday, Tuesday, Thursday and Wednesday. Even during the hours on which there are more data, this has lesser data on weekends than compared to weekdays. And so we can infer two things here. One is the number of calls increase as you go through the day, and most of the calls happen around this time from 3 to 7 in the evening. And similarly, most of the calls happen on the weekdays. There are more calls happening on the weekdays than on the weekends. Now let's create a cluster map for this. The size is too big, so we will make this smaller so we can read this. Here under the cluster map, if you check the signature, we have a parameter given for figure size. By default it is given 10 by 10. We'll make this 6 by 6. So here we have used redis underscore r, so it has reversed the color map so that lighter color has lower value and darker color has higher value. And here all of the hours and days have been clubbed together to show all of the higher calls together and all of the lower calls together. So once again it makes sense that lowest number of calls comes late at night from midnight till early morning, as most people are sleeping at that time, and most of the calls come from late afternoon, late in the daytime. So early morning from 9, 10, 11, 12 till you see 4 and 5 in the evening, and then it starts dozing off as you go later and later in the day. The peak data is during 4 and 5 in the evening. And similarly for the weekends, as you see for Saturday and Sunday, those are clubbed together at the bottom of the cluster map, and all of the weekdays which has more calls coming in are clustered together as well. Now repeat the same plots and operations for data frame that shows month as the column. So here we had the weekday. So actually here we had our hour data on the columns, and now they want to see month on the column. Now we want to see month on the column. So what we could do here is create a data frame which says by day, month. So here we can copy this code and change the hour to month data. And this data matches here with what is given in the notebook. We have our days on the row index and months on the column, and we have total number of calls, as this data frame is given as a matrix. where the actual data in the cell relates to the column and uh, row index. So we will create a heat map using this. So here for data, we will pass our new data frame, which is by day month. So here we have our day data on the row index and our monthly data on the column index. And if you remember, while analyzing earlier, we realized that the data actually starts from December of 2015. To be precise, it started on 10th of December of 2015 and went till 24th of August of 2016. So we had incomplete data for this December and for October months. And so obviously the number of calls were lesser compared to other months. So these two are clubbed together. The other months are clubbed together, but you don't see any specific pattern here. Once again, the Saturday and Sunday are little lighter compared to the other days. So clearly in terms of days of the week, we see that there are more calls coming in on the weekdays than compared to the weekends, but you don't see anything based on month. Let's check this for cluster map as well. Here, so if you see on the y-axis, once again the weekends have been clubbed together and weekdays have been clubbed together, and once again the August and December months are clubbed together and rest of the months are clubbed together. So in this project, we found that more calls are made on weekdays than weekends, and also more during late afternoon and evening hours than compared to late nights and morning hours. That kind of makes sense, as people are most active during those time frames, so there would be more traffic calls and maybe even EMS calls. However, there was no pattern observed for the month's data, partly due to missing data for the fall and winter months. If we find the missing data, then it could be analyzed for different reasons for summer and winter months, as there could be more fire incidents in the summer months and more traffic related calls in winter months. So that's all for this project. If you want, you can continue exploring this data further, but for now, thanks for watching.